Good morning, each and every one of you. Hope you've had a good weekend. Today's maths is going to be carrying on from where we left off on Thursday. So if you recall, Thursday we looked at dividing 4 digits by 1 digit using that short division method. And that's exactly what we're going to be doing today. Except compared to Thursday, you'll notice that we're going to be using remainders, or at least should I say finding remainders from our questions, which is something some of you may be familiar with, some of you not, but we'll look at doing it. And the beautiful part about this is no different to what you did last week. So you can see here we've got the question 4,364 divided by 5. So the first thing we know is to do the short division bus stop method. Okay, so we know our number that we're dividing by goes on the outside, and the number we are dividing goes underneath. Now, if you recall what we said we would do on Thursday, is actually to list the multiples of the number we are dividing by. So we've got 5, 10, 15, 20, 25, 30, 35, 40, and then 45. And hopefully you should remember why we do this, because of the significance in terms of working out our question. So here we look at now how many 5s go into 4. So if I've got 4, remember how many 5s will go into that. Well, we know if we look at our multiples down here, there's no multiple smaller than 4. So we don't have any 5s that can go into 4. But we still have this 4 left. So that is our remainder. So that remainder we pop there. So then we look at how many 5s go into 43. So this is where this list here is going to help us, because we can see all the way down here we've got 40 and 45. Now remember, we don't go over, so we go under. So we look at 40 and we know that is 1, 2, 3, 4, 5, 6, 7, 8 lots of 5. So 8 lots of 5 go into 43 with a remainder of, well, the difference between 40 and 43 is 3. Now we look at how many 5s go into 36. The same principle. We look down here. Wow, we can see we've got 35 and then 40. Well, 40 is too big, but 35 works beautifully because it's just beneath the 36. So it allows us to go 1, 2, 3, 4, 5, 6, 7 lots of 5 go into 36. And the difference between 35 and 36 is 1. So we have that remainder 1. We then look at how many 5s go into 14. So we can see, well, we've got 10 and then we've got our 15. So we know the 15 is too big. So it's the 10 that we focus on, 1 and 2. So 2 5s go into 14, which leaves us a remainder of 4. Now, at this point, some of you can write this: 872 remainder 4. And that will be an acceptable answer, because you're telling me you know 4,364 divided by 5 is 872 remainder 4. And if you do that, okay. But what I want to also see is some of you challenging yourself. Now, to challenge yourself further, what we have to do here is extend our short division method. And because we're now at the point where we have our ones, we put in the decimal point. And currently we have no tenths. But what I can now do is, we know we've got a remainder 4. So I can carry on my remainder 4. And now I can look at the next step of how many 5s go into 40. Well, we all know that straight away. We know 5 times 8 is 40. So I can put an 8 up here. So we know 872 remainder 4 was right. But if we wanted to be exact, we know that the answer is 872.8. So there's 2 potential routes you can take on this, and we'll look at it with the next example as well, so you can see how that works. And that example is this: 8,367 divided by 6. So first of all, let's lay out the method as we need to do so we're ready to go on that front. And then we'll stop. Because if you're confident with what you're doing, I would like you to pause the video. I would like you to give this example a go, and then you can play the video when you're ready to see if you're right up to those steps. Okay, so if you're going to pause now. And let's see how we get on with it, whether you're still with me or you're back. So we know we should be listing our 6 times table first because it's going to help. So we know 6, 12, 18, 24, 30, 36, 42, 48, and 54. And again, just a reminder, because we're focused on the method here, you can use a multiplication grid to help you with this today. That is absolutely fine. So now we can look at how many 6s go into 8. Well, look, we know 8 is bigger than 6, so we know we've definitely got 1. But what's the difference between 6 and 8? It's 2. So we have that remainder 2 there that we exchange. Now, how many 6s go into 23? Well, let's have a look. 23 is bigger than 18, but it's not as big as 24. So it's 1, 2, 3. And then we need to look at the difference between 18 and 23, which is a remainder of 5. And then we look how many 6s go into 56. Well, instantly we can see down here it's 54, and 54 is not even as big as 56. So we know that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 6s go into 56 with a remainder of, difference between 56 and 54 being 2. So a remainder of 2. We're now looking at how many 6s go into 27. So if we look at our list of multiples here, we can see 24. 24 is less than 27 and compared to the next multiple, which is over. So 1, 2, 3, 4. So 6 4s, or 4 6s even, go into 27 with a remainder of 3. So now this is where you remember have those two options. You could give me the answer here of 1,394 remainder 3, or as we looked at, you can carry on the short division method, decimal point, because we're already at the point of our ones here, and obviously we would have no temps currently, but we have that remainder 3 to bring over. So that's how many 6s go into 30? Well, 1, 2, 3, 4, 5. So then we actually see that we get 1,394.5. This part here is the challenging element, okay? But that doesn't mean you can't give it a go, okay? We should all get to this point. It'd be brilliant if we could all give this area of the maths a go. So you're going to have to concentrate here, okay? Because the remainder element is that confusing part, but you've got 2 examples to go back and see as many times as you need to then give it a go yourself. On this part, if you end up with another remainder here, which you could do, you then only worry about 2 decimal places, so you might have 0.56. You wouldn't carry on beyond that because then it's not an efficient method in doing so. So once you're happy with this, you've obviously got your choice between the questions on A and B, and obviously you know all of these are going to have remainders, you know the steps to take, you know how you can show your answer, and then you'll think, you'll explain, and you'll solve. On your think, there is a 3-digit number that when it is divided by 9, the remainder is 3. When it is divided by 2, the remainder is 1, and when it is divided by 5, the remainder is 4. What is my number? So you're going to have to find a number that fits each of those categories, which is doable. My advice to you is to have a look at the number you're dividing by and what the remainder is. Consider the multiples. The one I will help you with is this last one. So when it is divided by 5, the remainder is 0. We know all multiples of 5 either end in 5 or 0. So if there's a remainder of 4, that means you're likely to be looking at a number that ends in a 9, because 5 add 4 is 9, or 4 itself because of 0 add 4. It's going to have to involve a little trial and error, but we know that you're confident in doing so give it a go. Then on your explain, you're told a 3-digit number made of consecutive descending digits. So descending is going down, and consecutive is one after another. So in this example here, 7, 6, 5, they are consecutive digits descending. So these 3-digit numbers with consecutive descending digits divided by the next descending digit, so 7, 6, 5, and 4, 4, 3, 2, 1, always has a remainder of 1. So here's one example, but you're going to need to work out other examples to see whether that is the case, and to go, well, it's never, but if I'm really giving you an example, is it sometimes or is it always? Okay? And then for your solve, you have to write a number story for this calculation. What it means by a number story is like a word problem. So you've got 8,035 watts and you're dividing it into 4 watts. And with the remainder, you've got to do it where the story rounds the remainder up. So it might be marbles. Okay, think of a logical story where you would then go up to the next whole number, or in this case where you go down to the next whole number, or write a number story where you have to find the remainder. So it's going to require some thinking, but that's where you might want to explore the internet and get some help on that front. But as always, Mrs. Williams and I will be here to help you. We'll look at stuff like this at 10 o'clock. I imagine some of you will have questions on this, which is more than fine, and we can look at those there. So bring those questions along, and we'll see you at 10 o'clock to see how you're getting on with this. Take care till then.